All right. Hey guys. Sorry I can't be there in person today, but hopefully I'm learning some cool stuff at my conference. We're going to go through notes number 3. So you should have gotten a paper copy of this. I'm going to do my best to talk our way through it. Make sure you are filling these out as I go through it, or kind of watch and pause the video if you need to, as you need to write stuff down. Okay, so we're going to start with another way for graphing. So yesterday in class we talked about, or the day before we talked about graphing an equation, right? And we did that by finding the x-intercept and the y-intercept, plotting those on the graph, and then connecting those 2 points to make our line. Sometimes that's not always ideal, and we want a better way to graph. Also, it's only putting 2 points on our graph. So we may need to get a few more points to make it more accurate. So we're going to see another way to graph, which is by using a table of values. This is probably, even though it won't be the one that you remember the most, this is the most important type of graphing that we do, because as you move on in your math career, every single type of equation you look at, every type you learn, you will always be able to use a table of values to graph any type of equation that you're doing. Okay, so it's important that we understand how to use this. Okay, so to start with our linear equations to graph with the table of values, it always makes it easier to start by solving your equation for y. Sometimes it'll already be solved. If it says y equals, then that step is done. Sometimes, though, we want to get y by itself, and that's going to make it easier when we set up our table. So I'm going to take my equation here, it's y plus 2 equals 3x, and I'm going to solve that for y. So to get y by itself, all I need to do is get rid of that positive 2. So I'm going to subtract 2 from both sides. All right, so then my 2's go away here. I'm left with just y on the left side. And then on the right side, remember, I can't do the 3x minus 2 because those aren't like terms. So I'm going to write them in that order, 3x and then minus 2. So I end up here with that equation, y equals 3x minus 2. I have solved for y. I've got y by itself, right? Okay, so now, because we have that solved for y, it's going to make our table a little bit easier to do. So what we're going to do is we're going to pick several values here for x to plug in, and then we're going to solve for the values of y that go with those x's to make our ordered pairs, which are points on our graph. Okay, so in this middle section here, this is where we're going to show our work. So I'm going to take this y equals 3x minus 2, right? And I'm just going to take the part that's after the equal sign, and that's what I'm going to put in my table here. So 3x minus 2. That's what I'm going to plug my x value into to get my y value. Okay, so now when I go to pick some numbers to plug in, everybody always says, well, what numbers should I pick? Normally there's going to be some smart decisions here, but we'll start with just some easy ones. I want to kind of get points on both sides of my graph. So if I want to go in the middle, I'm going to pick 0, right? And 0 is always an easy one to plug in. And then I want to pick some positive values. So I'm going to pick positive 1 and positive 2. And then I also want my graph to go like fill up the other half. So I'm also going to pick some negative values, negative 1 and negative 2. Okay. And now I'm just going to plug those numbers in and solve for what my y values are. So I'm going to take my 3x minus 2 here, and I'm going to do 3. I'm going to plug in my negative 2 for x. So 3 times negative 2 minus 2. And if I work that out, 3 times negative 2 is negative 6 minus 2, which is negative 8. So my y value there is negative 8, right? When I plug my x value in here, I get that is equal to y. So in this case, when my x value is negative 2, the y value that goes with that is negative 8. So I've got my first ordered pair, which is negative 2, negative 8. Remember, our ordered pairs are always x comma y, right? And then I'm going to do that 4 more times, right? So I'm going to do that with the negative 1. 3 times negative 1 minus 2. That'd be negative 3 minus 2. which is -5. So my y value when x is -1, y has to be -5 to make that equation true. So my ordered pair there is -1, -5. And we'll keep going. Plug in 0. 3 times 0 minus 2. Well, 3 times 0 is 0. Minus 2 will give us -2. So our y value is -2. And our ordered pair is 0, -2. Notice that's also our y-intercept, right? Whenever we do the x value equal to 0, that's where we get our y-intercept. Okay, keep going. So now I'm going to plug in +1. 3 times 1 minus 2, which is 3 minus 2, which is +1. So with an x value of 1, we get a y value of 1. And finally, 3 times 2 minus 2 would give us, whoops, an extra parenthesis there. That would give us 6 minus 2, which is +4. Okay. So now I've got 5 different ordered pairs down here that are all solutions to this original equation, right? If I go back and plug in an x value and plug in a y value, it will make that equation true. These are all possible solutions of that equation. When I graph all the solutions to a linear equation, all those points line up in a line, right? So now I'm going to take all my points that I've got over here and I'm going to plot them on my graph. When I plot them, they should make a line. If they don't, that means I've made a mistake somewhere, right? Okay, so start plotting my points. -2, -8. Kind of just to fit on here. There we go. So -2, 1, 2, 3, 4, 5, 6, 7. Oh, it goes a little bit off our graph, but that's okay. I'm just going to go down 1 below the graph there. Then I've got -1, -5. So that goes there. 0, -2. Go here. See how my points are all making a line, right? If I go to plot one and I end up with one way over there, I know I've made a mistake. It's not staying in the line, right? So all your points should end up in a line. My next one is +1, +1. And then the last one is +2 and +4. All right, so all my points look like they're in a straight line there. So once I've got all my points plotted, I'll draw my line to connect those, arrows at both ends to show it goes on forever. And we've got a graph of our line, right? These 5 points that we made are definitely solutions, but then any other point that I choose on that line would also be a solution, right? Any other point in between there. Okay, so that's the basics of graphing with a table of values. You're just picking x values to plug into your equation, see what y value goes with it. That makes an ordered pair, which is a point on your graph. Plot all those points, and then draw a line to connect them. Okay, let's try a couple more here. And notice I've kind of made my tables a little bit smaller. And you can decide kind of how much of the table you want to show. Up here, I'm showing all of these steps. If you can do some of that arithmetic in your head, that's totally fine. Just make sure you're careful about plugging it into calculator correctly or writing it down. You'll make less mistakes that way. Okay, so same idea on this one. I'm going to pick the same x values to plug in. I want something in the middle. I want a couple positive values, and I want a couple negative values, right? And by the way, the order of these numbers does not matter. I tend to go from smallest to biggest, so that's why I put them in that order. But this order of those numbers doesn't matter at all. Okay, so now I plug each one of those in, right? Now this y equals part, I can kind of ignore that. I don't really need that. It's just to show me that that's the equation I'm graphing, right? I'm going to plug in my x value for the x in that equation. So when I do this, I'm going to get -4 times -2 is my x plus 8, right? Now this time I don't have enough room to show all that work, but again, I could type this in my calculator or do the work in my head. So -4 times -2, that makes a +8. And then +8 plus 8 gives us 16. So we get an ordered pair of -2, 16. Okay. Now on this one, I noticed right away that that is not going to fit on my graph, right? If I go -2 and up to 16, it's going to be way off my graph. So in this case, maybe I catch that and I think, well, that's a little too big. So maybe instead of using that x value, I should use something different. So we can kind of look at that when we keep going here. Well, let's see if the next one is going to fit on our graph. So I'm going to do -4 times -1 plus 8. Well, that gives me +4 plus 8 gives me a 12. That's still going to be too big to fit on my graph here, right? It's going to go up past that number. So in this case, I may rethink this and say, well, instead of doing -2 and -1, I probably need a couple more positive numbers instead, right? So if you get one like this where the numbers go way off the graph, you may have to rethink which values you're picking over here. In this case, I'm not going to make a big deal out of it. I'm going to just keep this as my point. I think the next couple I'm going to be able to get to graph, right? So let's see, -4 times 0 plus 8. That would just be 0 plus 8, which is 8. That one's going to fit okay on my graph. And then if I plug in 1, that would be -4 plus 8, which gives us +4. That one will definitely fit on our graph. And then -4 times 2 plus 8 would give me a -8 plus 8, which is 0. So we get a point at 2, 0. Okay. So again, this might be, these two up here are not going to fit on my graph. So I could go back there and instead of doing these negative x values, I might plug in 3 and 4 to get a couple other numbers on my graph. Okay. But in our case, we'll just plot the ones that we can fit on the graph. So I've got 0, 8. 1, 2, 3, 4, 5, 6, 7. So that is one spot above here, right? Let's use a different color so we can see it better. So 0, 8 would go there. Then I've got 1, +4 go here. And then 2, 0 would go there, right? And if I connect my 3 points, kind of, try that one more time. There we go. We get our graph. Okay, so it's okay if you get a few points that don't fit. Just plot the ones that do fit, or you can change around those numbers to make it work. Okay. Okay, a lot of time when you do this, we're going to get an equation like this that has this lovely fraction, your best friend, in it, right? Now, with this, we're going to be smart because I know how everybody is. Even though we can change fractions to decimals, a lot of people on their graph don't like to plot decimals or fractions. So if you are one of those people, you can make some smart decisions when you choose your x values, right? Whatever number I pick to plug in for that x, I'm going to have to multiply that number by 1/2. Multiplying by 1/2 is just like dividing by 2. So whatever number I plug in here, I'm going to have to divide it by 2, which means if I pick even numbers for x, when I divide by 2, I'll get a whole number instead of another fraction, right? If I chose 3 to plug in for x there, 3 times 1/2 is 3/2. So then I'm having to deal with fractions. But if I choose 4 to plug in, 4 times 1/2 is 2. So I end up with that whole number. Okay, so that's what I mean about some smart decisions here. So I'm still going to pick 0. That's an even number. That works. But then instead of picking 1 and 2, I'm going to pick 2 and 4. And instead of doing -1 and -2, I'm going to do -2 and -4. That way, when I plug it in for x, I'm going to end up with a whole number instead of a fraction. okay? And this is on any of those problems. If you have like a 1/3 here, then pick numbers that are divisible by 3. If it's 1/5, pick numbers divisible by 5. Okay? You can make smart choices there to make those a little bit easier. Okay, so then when we go to plug this in, I'm going to do 1/2 of -4 minus 5. So half of -4 would be -2, and -2 minus 5 is -7. So our first ordered pair is -4, -7. Plug in my -2. 1/2 of -2 would be -1. -1 minus 5 is -6. So we get -2, -6. And I just keep going and plugging these in. This time I do half of 0. Half of 0 is still just 0. Minus 5 would be -5. So 0, -5. And I'm going to do +2. Half of 2, is 1. And 1 minus 5 is -4. So our next point is 2, -4. And our last one, half of 4 minus 5. Half of 4 is 2. 2 minus 5 is -3. So 4, -3. Okay. And picking those even numbers over there made it so that I made the arithmetic a little easier on myself. Okay, so now if I go plot my points here, I've got -4, -7, -2, -6, 0, -5, 2, -4, whoops, there we go, and 4, -3. And then we can connect those to draw our line. Here we go. Ta-da! Okay, just plug in points in, plot them, draw your line. Okay, one last quick thing. We've got a couple other types of lines we can run into. So notice here, these two, y equals -3, x equals 4. They look different. We talked about this the other day with a linear equation. You can lose one of the variables. That happens, right? Most of your linear equations are going to look like these, right? Where you've got a y and an x, a y and an x every time, right? The majority of the equations you see will look like that. But I can have one, this is still a linear equation, where I don't have x, okay? So looking at this from our table of values perspective, if I go to pick my numbers to plug in, so 0, 1, 2, -1, -2. Now, when I go to plug that in to y equals -3, there is no x to plug it in. This just tells me that no matter what, y is always going to equal -3. So to find my y values that go with all those x's, I don't have to do anything because y is always -3 every single time. I can't change it, right? So then all my ordered pairs have different x values, but they all have the same y value. Whoops, I forgot to change my x there. It should be a 1, right? So my x value is changing, but my y value is exactly the same every single time. Okay, so then when I go to plot those points, if I do -2, -3, -1, -3, 0, -3, notice where your points are going, right? They're making a line, but they're making a certain type of line. If I draw a line through those, that is a horizontal line. Okay. So when it only has the y equals a number, you're always going to get a horizontal line because the y values are always the same. So you get a horizontal line at y equals -3. Okay. Seeing that, maybe you can guess what's going to happen when I do x equals. So in this one, our y disappeared, right? This is telling us the opposite of the last time. This x value is saying x is 4. It can't change. X will always be 4. So when I fill in my x values, it has to always be 4 every single time. Can't change it. But the y value, because there's no y here, it can be anything I want. So in this case, I'm going to make my y value 0, 1, 2, -1, -2. I could make it -12, 368. It doesn't matter. But the x value stays the same every time. So then we get ordered pairs where our x is always 4, but the y value can be anything. So then when we go to plot those points, I've got 4, -2, 4, -1, 4, 0. And hopefully you can see what kind of line this one makes, right? They're all again in that line. This time, when we connect them, that is a vertical line. Okay, so if you get an equation where it says just x equals, that's always going to be a vertical line. And in this case, it's a vertical line where x equals 4. So that's where we put the line. Okay. All right. That is the basics of graphing with a table of values. Right? Pick some x values, plug them into your equation, plot your points, and then draw your line to connect them. Okay. Your homework for today, and remember, just try it the best you can. At least try to do 1 or 2 on your own. They're numbered just the odds, by the way. I took the evens off for you, so you'd have some space over here to do some work. Okay, so remember, start with solving for y. I'll kind of put your reminders up here, right? Start with solving for y. Got to do that first. So like this one here, y is not by itself yet. So I'm going to use some space over here to solve for y and get y by itself. After that, make a table, right? Make a table of values. And when you draw your table, I always kind of make a table like this. You can do x here and y here, and then put your equation right there if you want to show it that way. Some people don't need this space in the middle, and that's fine. You can just make x and y and make a table like that. I'm okay with that. But make yourself some sort of table so you can figure out, if I plug in these x values, what do I get for y? Once you've got those, plot your points, and then draw your line. Okay, so on each of these, solve for y, make a table of values, plot those points, and draw your line. And try several of them. See if you can figure out at least one before we come back to class on Tuesday. Okay. Tuesday, we will go over questions on homework 2 and homework 3 if you guys have any. We might do a quick little like exit ticket kind of quiz thing just to kind of see where everybody is and what we've learned, even though I was gone for a couple days. So you'll do some practice on tomorrow in class, and then next Tuesday we'll do a little bit of review and maybe a quick little exit tick at the end just to see how we're doing. Okay? All right, guys. I will see you guys on Tuesday. Have a good weekend.